start talking today about equations of lines and planes. This is our general topic. And as part of this new unit, first thing that we are going to talk about is vector and parametric equations of a line in R squared. I want you to ignore the first part of the title first, and I want you to have in mind that what we do right now is nothing else but equation of a line. Well, we've been talking about equation of a line for a long time. What we want to express equation of a line using vectors. But anyway, we are going to start with our knowledge from grade 9. That's the first thing that I want to do. What do I need to be able to write the equation of a line in grade 9? Well, first of all, you are going to tell me that I need the slope. Slope gives me the steepness of the line. We use the letter M for the slope. Is that enough? If I know the steepness, is that enough to define a line? Well, obviously not, because look what happens. All these lines that I'm showing here have the same slope, M. Now, I need one more thing to be able to fix that line where I want. And that extra element that I need is a point on the line. A point on the line. If I have a certain point A, let's say, on the line, I cannot move my line up and down. There is a unique line that will have this slope and this point on the line. Good. Now, how do I take these elements from grade 9 and apply them and do the same thing using vectors? First of all, I need to talk about steepness. Guess what's going to give me the steepness? The steepness will be given by a vector that has the same direction as the red line. So I'm going to call this vector black vector over here. The direction vector written on component will be A and B. So this vector gives me the direction. That's why I call it a direction vector. Direction vector. Now, that is the equivalent of the slope from grade 9. I need one more thing. I need a point on the line. I need a certain point on the line. Now, we talk vectors here. We don't really talk about the point on the line. What we talk about a position vector. A position vector that starts at the origin, of course, and ends at that point. I'm going to change the color of these.
Pictures as well as the leadership club.
So,
the leadership club and the interact
this
group.
is M, direction vector, and the blue one, let's call it RO, and that is a position vector. So, RO, whose coordinates are X, O, Y, O, it's a position vector. Now, I will go back and I'll come back to this part and I'll show you how to get the equation of the line using these two vectors. But before I come back to that, let's do this in a special case. I have here the same equation, the same red line as before. Let's see what's given here. I will tell you that I'm giving you a direction vector, the one that you see there. What are the coordinates of this position vector? 1 and 2. And I'm going to give you, so this is my direction vector. I'm going to give you a position vector RO, which is nothing else but 2 and 2. So I'm giving you these two vectors. What I wanted to do, I want you to be able to generate any point on the line using the two vectors that I give you there. Now, any point on the line is not necessarily the best way to put this. The best way to put this is, remember, we talk vectors, we don't talk points on the line. So, I want you to be able to give me a position vector for any point on the line. So I wanted to generate this point and that point and that point and that point and this one and this one and this one and this one and so on and so forth. All of those are points on the line and position vectors to them. Good. So we know what we want to do. Using M and R0. Before we do that, before we go to any point, how about we go to a specific point? I have two points there on the line. The point of coordinates 3 and 4. Again, points 3 and 4 is not what I want. I want a position vector, let's call it R, which is using in component form 3 and 4. Good. Can I write this using my two vectors M and R0? Sure, I can write. If you look a little bit at the algebra, 3 and 4 can be written as nothing else but 1, 2, 1, 1, 2, plus 2, 2. Okay, is that true? 1 plus 2 is 3, 2 plus 2 is 4. Oh, so it seems that is correct. What I need to do right now, I changed the, I don't know if you noticed, but I changed the, I'm using the new version of Notebook, and that's not, sometimes I don't know how it works. So, 3, 4, I just showed you that can be written as M or R0 plus M, or the nomenclature. RO plus M. Good. So this is my R. Algebraically, that's quite obvious, not a problem. Now, graphically, how do I show that? Well, graphically, what happens when I add RO? RO and RO is this one, and M is this one over here. What happens when I add them? I can use either the parallelogram rule or the triangle rule, the one that you like. What do you do to apply the triangle? The triangle rule. You move your M like that, and you get your new vector, the position vector, from here to the point of coordinates 3 and 4. So there you go. I generated a new position vector that takes me to a new point on the graph. That is R. Good. Let's do the same thing, but this time with the point of coordinates. Let's try to generate the point of coordinates -1 and -4. Again, I don't want to generate the point, I want to generate a position vector, -1 and -4. Again, using the direction vector M and the position vector RO. Can I do that? Let's try algebraically first, and then we'll see what it means graphically. If you look carefully, -1, -4 can be written as R0 to 2 -2, we'll work through the algebra in a second, times M, 1, 2. Is that true or not? Let's try to check the algebra first. -1 equals 2 minus 2, 2 minus 2, that's not correct. Oh, it's -3. Sorry, yeah, it's -3. Okay, let's see if that works. It's 2 minus 3 times 1. Is this correct? 2 minus 3, that's -1. Yes, this is correct. And the second one is -4 equals 2 minus 6. Yes, this is correct. So that it's negative 3 there. So basically what I was able to write, able to write the fact that R, the position vector that takes me to negative 1, negative 4, is equal to RO minus 3 times M. 3 times M. Now, how does that look graphically? Well, graphically, uh, first of all, I'm adding R0, so there you go, R0 plus or minus 3n. So what I need, in order to get the vector negative 3n, in order to talk about this vector over here, m multiplied by the scalar negative 3, I take m, I change its direction, I already did that, and now I multiply it by, so I change its direction, and I multiply it by negative 3, something like that. Right, and that is a vector negative 3n. So what I need to do now, I need to add the blue vector and this is my negative 3, there you go. That's my negative 3m. Negative 3m.
If we have the
But let's add these two vectors. I apply again my triangle rule of adding vectors, and the resultant vector is right here. Let's change a little bit, let's make it different color. Green, we like green. Good. So this is my vector, my new vector R, which is nothing else but RO minus 3 times M. There you go. Can I now do the same thing to get this point over here? Sure I can. It's just that I keep my RO and my M will be multiplied by a certain factor. I don't know, 1.5, or I don't know what's there. Can I get this point over here, this point, this point? Sure, I can get all the points on the line by playing with a scalar in front of M. So there you go, that brings me to the previous idea. How can I write any position vector that takes me to any point on the line? I can write it as R equals R0 plus a certain scalar t, let's call it t, times the direction vector n. Let's not forget t is a real number. This is nothing else but vector equation of a line. Vector equation of a line. Now, I can write this on components. Don't forget that R on components can be written as xy. RO is XOYO. In my case here, it was 2 and 2, plus a scalar, a certain scalar, E times my direction vector A and B. This is a notation I did. Let's write this on components. The x component, x will be XO plus A, y equals YO plus EB, where T is nothing else but a real number. What I got here is the parametric equation of a line in R squared. Good. Let's check the time. 14 minutes. We'll stop here. I will show you the example that I want you to do, and we'll stop here. So what I wanted to do, I wanted to find the vector and parametric equation of the line that passes through those 2 points, A of -2 and 4, B of 5